neural network. Yeah. So normally the invention, right? The invention, unless invention, there is no any research, there is no any theory, isn't it? So participants always, right? For me, invention does not come from the manual. It comes from the mind. So visualization in the real field. So you try to change your attitude towards visualization. You have to visualize be some product, some process or theory, whatever. So visualization which will be improving you in any field. So this is a justification, right? Early human invented the wheel. Here in the slide, you can see the picture. That is early human invented the wheel, and as of now, right, we have the transportation like airline transportation, right, and railway network, and also in 2025 we are going to have metro train. So all those things happened because of the inventions or visualizations. So they would start our visualization on particular thing. So this is my thing that I want to stress you. Please wait a second. So why CNN? This is a very important question. Why CNN? Normally, as you know that already, that is ANN. Okay, artificial neural network. It is a conventional method of algorithm. So the CNN is derived from the ANN itself. So when I say CNN, what I mean is it is a advanced layer. It is an advanced layer than the artificial neural network. So something can be added in the convolution neural network than the ANN. So I can say always that the CNN is very powerful than the ANN. I'm repeating again, the CNN is always powerful than the ANN. So here my question is that which will be the easiest way to identify the features of any images? Normally, any researcher, right? Any researcher or scientist or whoever will be dealing with data. So data science, right? Right now it is a very recent field, right? BTech data science are there. So every one of us in the world will be dealing with data. Okay, so when I say data, it means like, right, it consists of two-dimensional data or one-dimensional data. So however, okay, however or whatever, we'll be dealing with data. It may be like, right, we can go for medical data, right? We are having some images. Okay, if you go for engineering, so there are a lot of data. Even if you go for mechanical engineering, we have the data like some mechanical property data. If you go for civil engineering, there are a lot of data there, mechanical properties of the data they are using for concrete purpose. Okay, even since I'm from the remote sensing background, I will be dealing with a lot of data like parameter like radiations, temperatures, temperatures, atmospheric temperatures, global warming, and atmospheric constitute pollutant. See, globally, we will be dealing with the data. Okay, so how to find out the data or how to find out the features of the particular thing? Okay, so definitely I can recommend the CNN. It's a very effective tool than the AN. So I am telling you, okay, so this is it's important to you. Okay, here my question is that which will be the easiest way to identify the features? The option is that so whether it is an individual pixel or random pixel, or sometimes it's a group of pixel. In the picture, you can see, right, this is consider this is image, and we are having like pixels. Okay, normally when we talk about the image, the pixel is the smallest unit of the image, right? So we can say like spatial resolution of our camera, okay, 60 megapixel of camera there, right? So smallest unit of the image. What do you mean the smallest unit? This is the smallest unit of the particular image. So I can measure this value and I can measure this y value and the x value. So that will be called as the area of this particular pixel. Okay. So this picture in this slide we can see it's a group of pixel. Sometimes if you want to make it some individual pixel. Okay. And another thing that I want to say is that when we talk about the ANN, that is artificial neural network, as we know that it is a biologically inspired network. I'm right. Biologically inspired network. So both CNN and as well as ANN is a biologically inspired system. It's like a human. Okay. It's like a human. I want to make the human or like a system. Okay. I want to teach something to the system. Okay, so this is what happening basically in the artificial neural network or CNN. Okay. So, okay, coming to that, the question is that individual pixel or random pixel or group of pixel, which will be effective or easiest way to identify the features. Okay, so normally, as I said before, the ANN does allow the pixel, individual pixel only or random pixel. So very difficult, right? You have to send, even in my research, right? One of the objectives is like that only. I want to taken out this particular image because my research title is that mapping and species identification of the tropical mangrove forest. Okay, so in which I want to map the species level mapping, isn't it? Species level mapping. So I want to get the unique pixel of the images for mangrove species. So by the time what I did is I allow into a particular process, I allow single pixel or 2 pixel, 3 pixel or random pixel. So very difficult to allow single pixel or random pixel and finding the object, right? I mean, finding out the output, it's very difficult and very tedious. So in which the CNN able to replace such a technology. So very, very advantageous. You can make use of any field. If you have any one-dimensional data, okay, if you have any two-dimensional data, because I am saying this, the CNN is always 3D neuron. It consists of 3D neuron. Even when we talk about ANN, it consists of like single dimensional neuron and as well as 3D neuron. But if you go for CNN, it strictly allows the 3D neuron. Okay, so if you have any images, you can feed the images into the particular system and see what's happening virtually. Sometimes virtually it's not possible. You have to go for imagination, sir. What's happening inside it. So my lectures, okay, will be able to understand or will be giving the what's happening inside the CNN, so that after ending of the session, we make use of this concept or take some images or take some one-dimensional data and try to do it. Okay, so coming to here that so individual pixel it's not possible. It's very tedious. So what I need to do is I collectively take in the pixel, group of pixel. See here in this slide, I can take a note 1, 2, 3, 4, 5, 6, and 9 pixel I'm taking, collectively taking out. Okay, sign pixel. So what I mean is instead of taking the individual pixel or render pixel, you take the group of pixel so that you can get effective output. Okay, so this is my suggestion for you. Okay, what does basically the CNN is doing the image recognitions and image classifications and object detection. It's a very important component, right? Object detections. Many researchers are doing this kind of work. If you go for CSE people or IT or any kind of multidisciplinary people, right? They are using this object detection and recognition spaces, etc. Okay, so this is what basically the application of the CNN. So we know that as you know that this is according to the Yu Zhang et al. I mean, he said right, it's artificial intelligence. It's a main part of this. After that, the subset of this we can derive from the artificial intelligence is machine learning. Okay, so deep learning is a subset of this machine learning. So there is a difference is there. Okay, so what is the artificial intelligence, machine learning, and deep learning? But in this case of my particular lectures, we'll be dealing with the deep learning, like convolution neural network. So this is the thing we are going to see that right now. The deep learning is starting from the 2010 and up to now. Okay, it is a vital role in engineering field. Not only in engineering, but also if you go for medical sector. Okay, even 2 years back, okay, it's CNN's great contribution for COVID-19. So direction of, for example, n number of people are there affected. Okay, so I trained, I made one system able to train. Okay, I given some of the programming to the system. So now the system is automatically detecting the COVID-19 patients, whether it will be affected by the COVID-19 or not. Because there are n number of patients may be there, like millions of patients may be affected, right, globally. So I can take out the pictures from millions in number of people and fed into my system. Then the system will be able to give these results of that implication, whether it particular person affected by the COVID-19 or not. Okay, so definitely it is a great contribution in medical sector also. I mean medical sectors, medical electronics, biomedical engineering, and whatever. Okay. Okay, coming to the convolution layer, I said before it is small. Even as much difference are there between the ANN and CNN, but the main difference is that it has the advanced layer. It has, I repeating, it has advanced layer than the ANN. So that I am saying is it is a effective tool than the or powerful than the ANN. So the efficiency will be improved, which means what? Accuracy will be improved. Why you want to find out the accuracy? Because normally when you go for CNN or ANN, we'll be using for image classification. So when I say image classification, the accuracy is important. So determination of the accuracy is important. But I don't know whether you are doing correct classification or not. According to your convenience, you may classify. But that classification may be misclassification according to my review. Okay, so validation is very important. Even you can make use of this CNN and ANN may be useful for validation of the results. I think some of the participants may be from research side, maybe research scholar or PhD scholar. If you have the work, you can go for this kind of advanced algorithm to validate your results. If you go for particularly, if you go for that image classification work or object identification or one-dimensional dealing with that also. Okay, so you make use of this field validation because if you go for this any kind of research, okay, if you go for like a CA or a CI, okay, a repeated journal, they will be asking that validation of the results. Directly they go for the method and they check it out whether or not validate the results or not. Okay, so that will be a very important part. Okay, so as I said before that it has advanced layer. Such layer is called what is exactly convolution layer. So normally, right, this will be already studied in the convolution in mathematical part. Okay, so application of the convolution. This is what, right? Normally, when we go for engineering people, right, maybe studying like mathematics 1, mathematics 2, even they go for that eigenvalue and eigenvectors and characteristic of the eigenvalues, Haley-Hamilton theorem, and whatever, right? And the Fourier transform. So all Laplace transform, whatever. So all those things to be implemented here only. So normally we would understand what is application of the particular thing in mathematics. For example, application of the eigenvalue where, application of the eigenvector in where. Okay, so normally matrix will be dealing for matrix. Okay, because the computer will allow the image, right? Let us consider this is image. This image consists of rows and column, like grid format. Okay, the computer can accept these rows and column. Okay, so read the images through the binary number, right? What about this value, this value? So it's very difficult if you go for that large number of data. So nothing but we can say that dimensionality of the data. So in this picture we have like 3 images, right? 3 channels. If you go for like even when we talk about in my field remote sensing, in recent technology, NASA introduced the hyperspectral technologies also. Okay, India also ISRO launched the hyperspectral data. So hyperspectral data is like a curse of dimensionality. You have to keep the n number of bands. Even I need to have more than 300 bands. So very tedious to have this kind of data in computer because I'm not using any kind of cloud. Okay, I'm not using any kind of cloud. But if you go for nowadays, we make use of the clouds technologies. Okay, so cloud instance already know, right? Actually, we are doing this any kind of operation through the cloud. So all the data to be stored in the cloud. Okay, so I don't want to do much detail there. I come into this the particular session like convolution layer is the advanced layer. Okay, advanced layer. It is a more powerful than the AN. Okay, so let us consider the input images here. It consists of 3 channels. For example, red channel, blue channels, okay, and green. And this is like a dimension of this image. That is 32 cross 32 into 3. So 32 row and 32 column. Okay. Normally, if you go for image processing, particularly remote sensing, it deal with images like this. It is largest images. The size is very large. If you go for Landsat data, it will take cover up to 250 kilometers. 250 kilometers means what? It will be like it's complex. There are n number of row and n number of column. So how to deal this kind of data to the computer? It's a big question mark. The computer able to deal with that data. So said to be data dimensionality. Okay. So here I said this is the input image is given like 32 cross 32 in the 3 channel, and this is what we are going to convolve. Okay, this is what we are going to the convolution like kernel. Sometimes we can see that kernel size of the kernel. Okay, here 5 cross 5, even you can take 3 cross 3. Normally any scientist or researcher make use of 3 cross 3 and 5 cross 5. So it will be giving the good accuracy. See, listen, the accuracy very important part, because we are doing the classification work. So based on this accuracy, you got to change your what we can say, change your that iterations or process. Okay, so here let us consider this is a 5 cross 5 matrix of that kernel. This is to be feed into that input images. Why I am saying this? What I said initially in the first slide, I said you have to take the group of pixel, not individual pixel. Taking the individual pixel is NN, taking out the group of pixel is CNN. So simply I'm saying the difference between the ANN and CNN. Now understand, I think. Understand? So here I'm taking the group of pixel, nothing but 5 cross 5. So this 5 cross 5, okay, which will be dealing with these images. So here it is like a 3 channel. So we have to introduce the 3 channel also for convolution, isn't it? So 3 channel. So here also 3 channels. So here convolve the filter with images. So this is what happening. We are going to convolve with the filter with images, and they have to gently slider over on it. Okay, gently slider over on it. So one by one. Okay, so here I have to slide over it. Next I slide over on it. Okay, then I have to slide over on this and this portion, this portion, this one, up to this. Okay, up to entire this. So this is what basically the advanced algorithm, nothing but convolution. See here, this is what the input images, and this is a kernel size. Okay, so this is what we are applying basically kernel to the input images, and we will be getting finally convolution images, nothing but convolution layer 1. See, we can apply n number of convolution layer depending upon your requirement. For example, my input requirements may be like input parameter may be more than 10,000, 15,000, 800, I mean 8,000, 10,000, 20,000. Okay, so data may be very larger in size. Okay, so for that we can introduce this kind of CNN only. Okay, for dealing with this n number of data, you have to introduce this CNN. So this is what finally the convolution layer 1. Okay, this is the convolution layer 1 from this input images. Okay, so how to determine this? Normally you can you go for the dimension of these images. That is 32 cross 32. Okay, so this 32 subtracted with this filter size 5 cross 5. So 32 minus 5, it's like 27. Then you have to add with 1. So this is like a mathematical expression. We are getting the output. You'll be taking out this kind of concept in theory form. Okay, so we can get what 32 minus 5, 27 plus 1. So 28 cross 28. Okay, so 28 cross 28. Okay, so now what's happening here? Now the size is reduced. Now the size is reduced from the 30 cross to 30 cross. So now we can say this data dimensionally done. Okay, data dimensionality is done. Just data dimensionality is like a curse of dimensionality. So you have to reduce the data. Okay, you to reduce the data. Even if you can go for compression of the images, compression of the video. Okay, so this is also, it's very possible for you. Okay, so this is what this is another example here. Okay, this is what is a 5 cross 5 images matrix. Okay, so this is a value of each pixel. If you go for any kind of remote sensing images, the value of depending upon this object behind it. Okay, for example, if you go for like concrete or any kind of building, it will be giving high reflectance value. If you go for water, it is giving low reflectance value. So depending upon the pictures, for example, maybe there is no information this side. In this side there is no information. So here some information may be there. Okay. So if you want to make what kind of image is, suppose let us consider ANN, how the ANN will be dealing these images. How ANN is will be dealing, I mean, is how the ANN able to find this kind of images. So it allows one by one. Okay, for example, it allow one, or I allow another one, this one, or 0, or randomly picking up. Okay, randomly picking up this from this grid. It's a very difficult task, right? So here, this CNN is taking a group of 3 pixels, So 1, 2, 3, and 4, 5, 6, 7, 8, 9. So 9 pixels are there. This 9 pixel is fed into these input images. So I can identify something here. I don't know what kind of object, but little bit I understand. Okay, little bit understand. I come to know that what kind of object may be there. So I can say it's a very powerful, right? It's a very powerful than the ANN. Okay. So after that, right, it is will be fed into this 3 cross 3. So finally, we'll be getting these output images, the convoluted features. Okay. So you go to, for example, one cross 1, right? 1 and so 0, then 1, then 0 product with 0, 0, then 1 product with 1, 1, 0. So you can get 4 value. Okay, number is the number is 4. Okay, after that I can go for this 3 cross 3. So what is the additive results? I can get 3. Okay. So we got that is what we can say the stride. I'm telling you what do you mean with the stride. Okay, next I move the kernel size here. I can move this kernel size here. Okay, I can move the kernel size here, and finally we'll getting the output 4, 3, 4, 2, 4, 3, and 2, 3, 4. It is something like that. This output of these images. It is identified some features. That's it. Okay, so what kind of features will be giving a n number of input to that? Then the CNN model will be giving what it is. Okay, after giving n number of input images to the neuron, hidden neuron, okay, then the system able to find what kind of image it is or what kind of object it is. Okay, so this is what the convolution is happening actually. And I said, right, stride is very important part. Okay, so moving of the pixels. Okay, moving of the pixel. For example, here number of pixels over the input matrix. Okay, for example, first I slide over on this 3 cross 3. Listen, I can slide this kernel. Okay, I can slide the kernel on this 3 cross 3. Next, I shift to this 3 cross 3. Understand? Next, I can move 3, 4, 5, 13, 4, 5, 15, 23, 24, 25. Next, I can move 4, 5, 6, 14, 15, 16, 24, 25, 26. Okay. Next, I move 5, 6, 7, 15, 16. Okay, like this, number of pixels sits over the input matrix. Okay. For example, when stride is 1, then we move the filter to one pixel at a time. Okay. In other words, when the stride is 2, then we can move the filter to the 2 pixel at it and so on. Okay. So here, for example, instead of going for 1, next change to 3, 4, 5. Okay. For example, listen, I slide over the kernel on the 1, 2, 3, 11, 12, 13, and 21, 22 pixel. Okay. If we go for stride number 2, then we can go for 3, 4, 5. You can skip 2 pixel. You can skip 2 pixel. So 12, 3, 4, 5, then 13, 14, 15, and 23, 24, 25. Okay, so like this, you have to go for stride. You can go for stride until the position happening here. Okay, 55, 56, 57, right? So in this side. So you can start slide over from this portion to this portion. I mean from left to right, again from left to right, then from left to right, then from left to right. But normally the computer accept the vector here. Okay, I'm telling you in coming slides. Okay, so this is what a big problem, right? This is what big problem. Since it is accepting the vector, it's like a vertical column. So very difficult for understanding the really what it is picture, because normally the picture, right, the picture here, if we go for CNN, the 11 12 13 will be shifted is in row. Okay, actually it is 11 12 13 is here this position only, but the computer accept 11 12 13 in the row because it is flattened layer, because the computer accept in vector. I'm telling on the coming slide, you can understand easily. Okay, so far the convolution is over and the slide is over. Next we go for the padding. And this is it is not mandatory sometime, but it is necessary to go for replacement of the losing of the information sometime. Okay, even sometimes the filter may not be fit for the input images. Okay, so by the time we can apply the padding. Okay, so normally the researchers scientists make use of the zero padding. Okay, you got to add zero from this place. These are original images normally. Okay, then you got to add zero padding. This is right. Basically, in digital system or DSP, we are studying this kind of concept. Zero padding. Why we go for this kind of techniques? Okay, so retain the actual information. To retain the actual information, make use of the padding. We don't want to touch much details here. So this is another important fact is that is ReLU is one kind of activation function sometime. So it is a rectified linear unit. Okay, it stands for rectified linear unit for linear operation. So here the normally this expression for this ReLU is the maximum of that 0, x. Okay, so here the input variable is given. Okay, so you have to take maximum of this value. So here maximum always right, 0 is always right. Here it's minimum. Sometimes you go for the minus, the maximum will be 0, isn't it? So that all the negative pixels will be converted into 0. Let us consider this is the input images. Okay, let us consider, for instance, here 15, 20, minus 10, 35, then 80, minus 1 and 0, and 25, 100 and 20, minus 15, 25, minus 10, and 101, 75, 18, and 23. It is a 4x4 matrix, and sometimes the negative pixel also the may be there, depending upon the what kind of object behind it. So when we talk about normally in remote sensing, the water pixel will be giving negative value because less reflectance may be there according to the principle of electromagnetic interaction. The electromagnetic interaction will fit into the particular material is getting reflected. So the reflectance, it's not unique for any material. Depending upon the characteristics, depending upon the property of each material, will be giving the reflectance. So particularly when we go for the water, we'll be giving negative value. So here negative value in sense it is converted into 0. So this is what a drawback of that in remote sensing is concerned, because all the water pixel will be converted into 0. So the information is getting lost, right? I cannot identify what kind of object it is there. So better you should have these positive images like that. Okay, so that is what we will be giving the good results. Why I am saying this, in remote sensing is concerned, the water will be giving negative value. So actually when we apply the ReLU function to the input images in remote sensing is concerned, it converted into 0. So all the water information is getting lost. I cannot classify these water pixel. So this is what the big questions in the remote sensing is concerned. Okay, so ReLU always associated with convolution layer here. Okay, always it's associated with the convolution layer. Once apply the convolution, you have to apply the ReLU, which means rectified linear unit, because the CNN won't accept the negative value is concerned, so that it is converted into positive value. Here in the picture you can see all the values positive, 15, 20. Here no information. But here it is indicating something, 23, 18, 75, 101, 20, 15, something like that. Some features may be there. Okay, so this is what the contribution from the ReLU. So After that, after applying the convolution along with ReLU, you can apply the pooling layer. So here, pooling in sense, you have to take maximum pooling and average pooling and sum of pooling. So let us consider the input images. Okay, here 1 1 2 4 and 5 6 7 8 and 3 2 1 0 and 1 2 3 4. This is what basically this 4x4 matrix. And we are apply, for example, 2x2 filter on it, and the stride is 2. Okay, stride is 2. Okay, here you can make use of either one, maximum pooling or average pooling or sum of pooling. So normally the scientist or researcher make use of the maximum pooling. Okay, it's a very easy taking. For example, let us consider the 3x3. I mean 1 1 2 and 2x2 1 1 and 5 6. So which will be like maximum 6. So here 1 1 5 is replaced, here 6. So the entire image is sometimes is reduced here 2x2, isn't it? So 4x4 is reduced to 2x2. So what's happening here? It's compressing normally is taking place. Normally, even the compression is taking place here, but no information is getting lost. You have to keep in mind that no information should lost. It's a very important thing. Okay. After that, you can make use of the stride is 2, right? Stride is 2, so that you can apply here. 2, 4, 7, 8. Okay, because stride is 2 means what? You can apply here 2, 4, 7, 8. So which will be the maximum? 8 is maximum. So 8 is. So this is my handwritten ropes. Okay, it will be like very easy to understand. So that I take a note written in my paper and extracted here. Okay, then I can go for here 5 6 in these portions. Okay, 3 2 1 2, because stride is 2, so I can apply here only. If it is stride 1 means what? You can apply here 5 6 3 2. Stride here 1 means 1 2 6 7. Or here stride is 2, so that we can apply shifting up to position. Okay, so here 3 2 1 2. Okay, which will be the maximum? 3. Then 1 0 3 4, which will be the maximum? 4 is the maximum. Okay, so here and here and here and here. So it is reduced to the 2x2, and this is what is the maximum pooling. Even sometimes you can make use of average pooling. You can take the average from the 2x2. Yeah, 1 1 plus 5 plus 6, so 11 12 13 13 by 4. Okay, then 2 4 7 8. So 12 plus 7 19 21 divided by 4 average. Or I can take the summing pooling. You would add all these things. 6 plus 1 1 6 7 7 plus 1 8 8 plus 5 30. So here is the 30. So even I apply all these methods, the results will be uniform. So don't bother about that. Is there any changes in the results? No. Okay. So for you, this is a question for you. I can take down. What will be the output of 3x3 maximum pooling window when the below step input is given? Okay. So this is the input image again given, and you go to find the maximum pooling. You go to find the maximum pooling of this. Okay. So take down this exercise for you and do it after ending the session. Okay. So far I discussed, isn't it, convolution layer and activation layer, and now pooling layer. Understand? So now finally we go for the fully connected layer. This is what basically the CNN. Okay. Once the fully connected layer is done, so that is said to be the CNN, but it is not compulsory. You know, when we talk about the difference between the CNN and the ANN is always fully connected, but CNN is not there. We can disconnect at some time also. Sometimes some layer may be disconnected because there are n number of neurons, larger number of neuron is available in the CNN. Okay, some layer to be disconnected, possible. Okay, but when we go for ANN, it is always fully connected, always fully connected. Okay, here you can see, right, this is what input image given, x1 x2 x3 x4. It's a vector. We consider the vector. Okay, the vector is given to the neuron. Okay, each neuron. Okay, some hidden neuron is there. Okay, so we can get n number of neuron here. Okay, you can get n number of neuron here. And finally, we can get some output here. Okay, y1, y2, y3. It's the output section and this input section. Since we are giving here, it's 4 input is given. We are getting sometimes 4 input or 2 input, 4 output or 3 output or 1 output. Okay, so minimum we should have some 2 output is possible because we go for the comparison. Okay, based on the input images, what kind of image it is. So let us consider we are giving some elephant images. Normally, this kind of technique I deal with that elephant detection. In my one of the pattern is called CNN based elephant detection, in which I make use of the CNN model. The CNN model able to accept all these input images, which will be covering, which will be taking from that camera on the particular railway network. It accepting the input images one by one. Then finally, the model able to give the information about what kind of object it is, whether it will be like tiger images or whether it will be elephant images or human images, because there are a number of object may be crossing on the railway network. My aim is that you have to find out the elephant direction. Even the tiger may be crossing on that particular field. Okay, so the system able to understand what kind of that image it is. Okay, whether it will be elephant, whether it will be like tiger, and so on. So that I can introduce these hidden layer. Okay, so that I can introduce the n number of hidden layer. Okay, so finally we'll be getting output final. Okay, we can get final output here. So this is what the fully connected layer. So this is the overall steps involved in the CNN architectures. Okay, in this slide you can see, right, these input images given like elephant, like cat, or even you can view the input images like remote sensing images or any gray level images to be given to the system. I mean deep learning system like convolutional model. Okay, after that applying the pooling layer. Okay, then fully connected layer, and finally dense layer, and finally the classified output. Okay, so in this slide you can see the step by step you can given here. Provide input images into convolution layer, and you have to choose the parameter. I mean apply filter with stripes, padding if requires. So padding it's not recommended always. Yes, based on your input images. But I recommend you go for, I mean, if you make use of any remote sensing images, by the time the padding is maybe necessary. Because the information may be getting lost in case of remote sensing is concerned. Because it is covering that 250 kilometer, 250 kilometer, there are n number of objects may be there. So you take small images like cat, only the cat may be there. But if you go for remote sensing, it consists of larger number of objects, maybe water, like soil, vegetation, settlement, whatever. Okay, so the padding is required for remote sensing is concerned. Then perform the convolutions on the images, I mean input images. Then simultaneously apply the ReLU activation. So here one thing you have to understand, I said before that always the convolution layer is associated with the ReLU. Okay, so this is what I given with the convolution layer plus the ReLU. So always. So this is to be there because CNN always accept only the positive values. I mean linear unit here. Okay, so that a negative will be discarded here. After that only you can go for the pooling layer. Okay, then perform the pooling to reduce the dimensionality size. Yes, definitely it is reduce the dimensionality because before slide we have seen, right, the input images is getting reduced into some dimension. Then I can add as much convolution layer until your satisfaction depending upon your input image size. Okay, so convolution layer 1, convolution layer 2, and convolution layer 3. And even if you go for the convolution layer 1, you can apply simultaneously pooling layer also. Pooling layer 1 for convolution layer 1, and pooling layer 2 for pooling convolution layer 2, and so on. Okay, so till your process satisfactions. And finally, before getting output, should flatten the results because the ANN accept in the vector. So we should flatten the variable, I mean flatten the matrix like vector. So basically, right, we'll be this kind of subject will be studying in the mathematics 1. Okay, eigenvector and eigenvalue. So this is what the application of the eigenvector here. Okay, so see here the vectors will be allowing input to the images. Okay, here. Okay, here x1 and x2 eigenvector here, x3, x4, x5, x3, x6, and so on, depending upon the size of the dimension. Okay, see button. So flatten to be done. Okay, flatten to be done after cooling layer. So now the images is reduced in this like this. So that I'm saying that it's a very critical part here. See here here the informations is the horizontal information may be here. Okay, horizontal information may be reduced to vertical. So this information is converted only here. This information converted here. Okay, so this is a very confusing part for the computer. Okay. So this is what the overall example here. Okay, the input images convolution layer is given, and finally we're getting the convoluted layer here. Then you have activation function to be here, remove activation function. Then it will be reduced to -2 converted to 0. Okay, so this is what the good example for you. After that, applying the relay layer, we will getting output. Okay, 2 3 2 0 2 1 0 1 0. Because I converted to -2 into 0, and okay, and then there is no any negative here. Sorry for disturbance. Some work are going on other side. I think. So after the convolution layer, we are applying the relay layer, and we are getting the output here. This is what output of this particular input images. So this is what the input images here. Here input images. So 1 2 3 4 5. So 5 cross 5. Now the 5 cross 5 is reduced to 3 cross 3. 5 cross 5 is reduced to 3 cross 3 here. Okay, so data dimensionally done here. So after that, we can apply the cooling layer. Okay, listen. So 2 3 2 0 2 1 and 0 1 0. Okay, it's taken here. So 2 3 2 0 1 2 1 and 0 1 0. Here I take the maximum cooling. Okay, so you have to take the maximum 3, and here 3. Here is straight is 1. Okay, here straight is 1. So 2 3 0 2. What will be the maximum? 3 is the maximum. Okay, so 3 2 2 1. What will be the maximum? 3. And here 0 2 0 1, which will be the maximum? 2. And 2 1 1 0, which will be the maximum? 2. So now again it is reduced to cross 2. See, listen here. Input images is 5 cross 5. Now the output is here 2 cross 4. Isn't it? As much reduction happening here by using the CNN. Okay. So after that, the flatten layer is that you have to flatten the images, right? I said right, flatten the images. So this is what you can see in the picture. Flatten layer. You have to flatten the variable by matrix value. I mean, in terms of vector. Okay. How to change? Simply change, no problem. So listen, 3322 is a final output. Okay, so then you can flatten. So 33, then 22. Okay, you can flatten 3322. Now this is what is giving. 3 it is giving to the input, and 3 is another giving to the neuron, and 2 is giving another neuron, and 2 is another giving another neuron. Okay, so depending upon the input requirement, you have to initialize the hidden layer. Okay, so this is what we can go for the implementation part. In implementation part, you have to give this kind of input images. Okay, dimensions. Okay, so this is what the flatten layer is giving to the dense layer through the weight, different weight. So this is what happening. This in mathematical expression here. Okay, so this is output of this dense layer. We can say A equal to W, weight of that, and plus this bias. Okay, so finally we are getting this portion. So dense layer A1 and A12 and A13 and A14, and we'll be getting this kind of mathematical expression like matrix 1. Like matrix format. So this is what the application of the mathematics on here. Okay. So after that, I can go for cities, do the convolution layer. I mean, then remove activation layer here. Okay, all those things happening. Okay, entire system. Okay. So this is what basically the output system. Okay, output system. So before giving the output, we got to do the flatten layer, then dense layer. Flatten layer, dense layer. The output of this convoluted layer here, right? That will be flattened here. The flattened is given to here, which consists of like some weightage here, weightage of the neuron here. Some neuron may be very dense, some neuron maybe will be giving weight results, right? Even in a human, right, some neuron may be getting some unhealthy. Okay, some neuron may be healthy, some neuron may be unhealthy. So depending upon the nature, because I said, right, it is biologically inspired. These are biologically inspired. So depending upon neuron, it has given some weightage here. Okay, then finally we'll be giving the output like 8, 7.1, and 7.4, and 7. Okay, so this is what basically the dense layer. From the dense layer, we are getting final output here. Okay, so here I can comparing two images, two object. We give one images here. So, for example, let us consider. You can give here is like on elephant images or tiger images, or depending upon the data sets available in the open source also. Okay, we're having some data sets available. We can make use of this Python programming, make use of any data. The data will be given here. Then you can find what kind of object it is. Okay, so whether it will be class 1 or class 2. So all those to be done depending upon the probabilistic value. Okay, depending upon the probabilistic value. Finally, right, before classification, normally the classification through done the softmax activation function. So these are basically the formula will be involved here. Okay, this softmax activation function. This softmax activation function able to classify the object which is giving from this input side. Okay, so normally it will be lying between 0 to 1 always. It is always lying between 0 to 1. Okay, so depending upon the probabilistic value, okay, priority based. Okay, for example, the output of this 0.04. Okay, sometimes the output images may be 0.03 or 1. Sometimes maximum is 1. So maximum means what? It is a good classifications. Exactly what it is. Okay, so based on the priority, based on the probabilistic value of the probability, we will be giving the output results. Okay, so you have to take note the high priority value. So that will be the actual features depending upon the input features. Okay, now the object is identified from the input images based on the probabilistic value through the softmax activation function. Through the softmax activation function. So this is formula will be involving here. Okay, so normally I'm saying that here I'm showing that what's happening inside the CNN layer. So this like this it's happening inside the CNN architectures. So one thing you have to understand that you have to understand the hidden layer. Okay, this is what is very important section. There are n number of hidden layer is there comparing the ANN. Okay, so this is what the implementation side. You can make use of MATLAB as well as the Python. So Python's content it should have some prerequisite knowledge in the Python. Okay, it should have some NumPy. You have some experience in NumPy. Okay, matpilot, and how to plot the data, how to read the data, how to give input data. Okay, how to read the images. Okay, what are the library to be given for Python? So these are the basic requirements. Okay, so normally it is sequentially executed so that right we can give you like a sequential model. Okay, so now what's happening here is that I make use of model. Okay, I make CNN model. Okay, now the CNN model able to train by the human. Okay, I'm giving the training to the system. Okay, you got to do the classification. If the input is given like this, you should do like child. Okay, we are teaching something to the child, right? So like this only, one CNN model is there. I'm teaching the CNN model, so that now automatically able to understand. Okay, after I am giving the training, now the system able to understand. If something is given from the third person. So this is what basically the CNN model tells us. Okay, so it will be done through the sequential. Here I am introducing the two-dimensional images because normally the image is two-dimensional, so you have to declare convolution 2D. And as I said, right, sign dimension is given, and size is given. Kernel size 3x3 and 32x32, and 3x3 is then always you go to activation is associated. Okay, ReLU is always associated with the convolution. So that the negative will be discarded. Okay, then the input shape is also given like 32 cross 32 and 3 channels. Then I go to odd maximum pooling. I'm not doing this kind of second option like padding. I'm not doing. I'm not doing. Okay, padding is not doing. Here I skipping. Then I go for the pooling layer. Okay, so I'm introducing this size, kernel size. Then simultaneously go for the activation function. Then activation functions. Then if you go for the model summary, it will be giving the output like this. Okay. So how many parameters iterated here, and input shape is given here. None is indicate that input images. Normally, the input images may be infinite. N number of data sets are given. Okay, n number of data sets available in computer. Even if you make use of Sentinel data is available. There are n number of millions of information. See, if you go for any kind of input images for training, you should have. You should give more than 500, minimum 300 to 400, 500 images to be given. So this is what difficult task. Even if you go for field visit, you have to collect a minimum 500 samples, 500 to 1000 samples. Very tedious. Okay, so this is what the drawback. If you ask me to what are the drawbacks of the CNN, let me tell that it is very tedious process to collect sampling. So you have to give 500 samples, 1000 samples to be the neuron. So that will be very difficult if you go for the images concern. Okay, the image is concerned, I have to take and I can accrue a number of images by make use of any sensor. Normally, we make use of the data from the particular service provider. The service provider may not be providing a number of data, right? So you have to create the data. So this is what the limitation of the CNN. This is what the limitation of the CNN. So none is nothing but the input dimensions. So you can give a number of information. There is no limit. That's why it's mentioned in the none. Okay. So all this layer is done here. Okay, this is what convolution is done. Then maximum pooling is done. Okay, all these things done here. Here I applied all the layer here. Listen, after applying the maximum layer, I applied here it's a flatten, and I applied here the dense and dense layer. Okay, flatten layer, and in the previous slides you can see the convolution layer, maximum pooling, then flatten, dense. Okay, all this layer is given. So all the layer is very advanced, which will be missing in this kind of in the ANN also. Okay, we got to skip some layer in the ANN, but you can here you got to follow all those layer in the CNN because it's a three-dimensional volume of neuron. Okay, three-dimensional volume of the neuron. Here total parameter is iterated here 1 to 2, then 570. Okay, all those parameters are trained. Okay, there is no non-trainable parameter here, 0. Okay, so this is a model, evaluating the model here. Then you can give this epoch is given. You can here like 10 times, which means what? You got to do repetition of that. Okay, like for example, I'm doing one work, then I'm repetition taking test, replicate. Okay, I'm doing 10 times a replicate. I'm again go to that particular task. I'm doing that again. I'm doing that. Okay, like this. So 10 times. Okay, so this is what is given. So you have to compile the model. You can have some library here, like right. Keras. I make use of the Keras here, and like library like cross entropy. This is a very theoretical part. You can go through it. Okay. Then finally the iteration taking place here. 10 times of epochs. So it will take to complete minimum 10 to 20 minutes to complete all those things. Then you can go for the validation of the results. Why we go for the validation? Because we want to check it of the accuracy. Okay. So because normally we are doing the classification accuracy. I mean, we are doing the classification of the images. Okay, so we can go for the accuracy. So here maybe the accuracy is maybe improved to 71% here. So if you want to make use of improving, you can do repetition of the process until get the higher accuracy. Okay. So in this picture you can see, right, this is a model of CNN summary, and here I make use of the Keras library. Here I make use of the Keras, and also it consists of various layers from Keras. Even I get some input from the Keras also, some data sets, image database available in Keras. Okay, so I make use of the Keras, and I introduce these all these layer here. Okay, flatten, dense, and activation function is also given. Finally, I made use of the softmax function. I made use of the softmax functions here. Okay. Before that, I can make use of the ReLU function. Finally, you go for this softmax action. The short-term action is maybe using for like probabilistic value based work. Okay, it is giving some values from 0 to 1. So based on the 0 to 1, I think it has some range. So based on the range, you can identify the material. So here, like you can go for the model summary. It will be like sequential functioning. Here, 784 is like a input neuron and then variable. Okay, sorry, not neuron, it's an input variable 784. And here I introduced 300 neuron for this input variable. Listen, for this input variable, I'm introducing 300 neuron. Okay, 300 neuron here. Okay, so this is the parameter derived from this concept. You have to multiply with the 784 into 300 plus bias, as much bias. Here 300 bias. So 784 into 300 plus 300 means this amount. Okay, this much amount of parameter. Now we can add here 300 into 100, 30,000. Then we can add here 100. So 30,100. Next we add here 100 into 10,000 plus bias 10 bias. So 1010 bias. So all these parameters, finally adding this all these parameter and the total parameter is this. All the parameters trained. Okay. Now after training is given, now your CNN model able to understand somebody is given input image to the model. Automatically detection. So then most of the researchers are doing automatic detections. Even in my work also in elephant detection, the CNN is doing automatic detection across the railway network. It is under process. So it is a very interesting technology, and also it has more information. You can make use of the technology in the field, particularly if you have 2-dimensional or 1-dimensional. Okay, it will be good, giving good results for you. Okay, so thanks for the opportunities from the Kiran sir who contacted me. Even I contacted from some other person who directed me to the Kiran sir. So Kiran